Hey guys, what's up? Eddie Alho here with KissAnalog.com. Today I'm working on this Class D amp, but Pico has released their version 7 software, so it's what they call the version 7 stable. I've been using the pre-release, and I'm going to come over here and show you the scope and how it sets up, and we're going to look at some Class D amplifier signals, okay? Alright. Okay, to the left is the Unity generator, and here is the Class D amp. There's a close-up of it in the box. There's the front panel where the input power goes to the one side, and both sides have individual controls left and right, but one side has the power. And over here in the corner is where the power comes in, runs up here to the front panel on-off switch, and there's a left and right channel. So one channel comes over here, they both come back here and connect right into the amp. That's the output of the amplifier right there. That's a really neat kind of heat sink, right? And that's the ICE amplifier. And look at the differential probes going up to the mix sig. So there's the differential probe going into it. So I'm using this Mixig differential probe here. He plugs into channel 3, the third one from the left. And the first one on the left is the new differential probe that plugs in. And there's my stack of resistors. So 2 8-ohm resistors. And the other 2 resistors are 4-ohm resistors. They're not connected. The bottom one's a 4-ohm, and then I have an 8-ohm, a 4-ohm, and then the 8-ohm. And the 2 8-ohms are connected. The 2 4-ohms in between are just used for heat sinking, and they work pretty well that way. And there's my Mac. So, with the Pico software running. Okay, so this is Pico's website, and here's the products, all the different scopes series they have, and they have other things as well. These RF products, data loggers, and a bunch of accessories. And their accessories are relatively low cost compared to other scope manufacturers, I think. All right, so over to the right, the PicoScope Early Access is what I've been using for about a year, a little over a year probably. And over on the left is PicoScope 7. This is the new release, the latest release. They used to have PicoScope 6 up here. So now they have this. It's in Windows, Apples, and Linux. I've used it in both Windows and Apple. Well, I've used actually PicoScope 6 in Windows and Early Access in Apple. Because this Mac that I'm using right here, I can use a program called Parallels that lets me run all the Windows programs, and it runs it just fine. Don't even notice I'm going through a different computer. So over here is PicoScope 6. It used to look like that, rainbow inside a sine wave, and then Early Access looked like this, and now we have this one. So let's go ahead and open it. You'll see a window right up here, and it found the scope that I had hooked up, so it just connected to it. But there's an option down below. If I did not have a scope hooked up, it would have given me an option of just running kind of a simulation, and I could have ran sine waves and looked at things without even having a scope. So you can download the software and play with it that way. All right, so here's the window. I've got my Class D amplifier running. You can kind of see the noise, the fuzziness on the waveform. Waveform's jumping around. Let me show you the first thing we like to look for in a scope sometimes is this auto setup. Let me hit that, see what it does. Okay, it looks a little bit better. It improved, but it's still jumping around. So now let me show you real quick. Over here on the left side is the channels A, B, C, D. Okay, and then digital channels and generator. I'll show you that in a moment. But up here we have our horizontal scale, and here's our trigger. Let's go to our trigger and see if we can get this thing to stop jumping around. Now, first of all, it's in auto mode. There is a repeat and a rapid, which is interesting, and an ETS. A little bit different than what we're used to seeing, because this is a really a digital trigger. instead of having low pass and high pass filters and that to try to filter out the noise, low noise, high frequency noise, low frequency noise, it does it in a digital way. I'll show you. Now, here's the sources, A, B, C, D. I only have A hooked up right now, so that's the only option I have. And pre-triggers right here, 50, and thresholds 93.2 millivolts. So I could click plus minus, put this on 0, or I could click in the middle and just say 0 millivolts, and then click over here on the screen. And 50% is right in the middle of the screen. It's right here. Okay. Now I can also just grab this yellow dot, which is the trigger point, and I can just move it up here. Now see, it's 29%, 800 millivolts. So I can just move this thing around. I can say place it right here. Okay. Now one thing, what I want to show you is first how we can make this waveform steady. Here's all this advanced triggering. Okay. You can see all the different types here. What I want to do is hit the advanced edge, okay? And it comes up with this hysteresis thing. And let me just go ahead and click on it a little bit. I'll just increase this value. And what you see is this line right here growing. And see how it got steady? So what hysteresis is when the waveform, we're on the rising edge, not the falling, or I could go either. And then it goes before, it jumps around again. But there's falling or rising. So on the rising edge, there's some noise here on the 0 volt line. And so it keeps on triggering. That's why it won't hold steady. So we could have done some high frequency, low frequency filtering like you do on other scopes. Sometimes it works, sometimes it doesn't. This thing pretty much should work all the time. Or you can choose one of the other ones and make them work. But for a noisy thing, this thing works. So see this line? I can also grab it and drag it and move it. Whoops. Move the whole waveform. I can grab it and move it like this. Okay? And shorten it. Basically, you see the noise. I just need to be wider than this noise thing. So I could probably take it up to here. Okay? And it works fine. Okay? So now let me show you why. I'm going to zoom in on this. Now this has deep memory. Really deep memory. Like really, really deep memory. So I come over to the magnifying glass right here. And first of all, this window, I love the window. You can move it around. Okay. Put it up here. I can use plus and minus to zoom in. See, I could go plus. You see how it brings in the top and bottom? I can grab them like this and move it this way. Okay. And I can do it this way too. I go plus, or I can grab the scroll bar. All kinds of different ways to do this. Okay. But what I'm going to do is I'm going to just zoom out again, just so I can see this. And I've got this selected. This hand thing would allow me just to move the waveform around, okay? Or move this around. But what I want to do is I want to go to this, and I want to put a box around that. Okay, now you see how we're zoomed in to the crossing point? Let me zoom in a little bit closer. There we go. Now, first of all, let me get this out of the way. First of all, this waveform looks like, doesn't look too great. It's kind of choppy, square looking. I can zoom in on the horizontal a little bit more, so spread it out and show you the squares. See this? This is a 8-bit scope. Because we got such a big voltage range here, and now we're zooming in on this teeny little spot here. See right here, 57 millivolts to minus 300 millivolts. So we got about 350 millivolts top and bottom. And we started off with, see this thing up here, 5 volts? That really means 10 volts top to bottom. And I'll explain that in a minute. But, or I'll show you how that works. But, so what we can do on this is, I can go here where it says 8 bits hardware resolution, and I can say, let's go to 12 bits. Now look, now it's kind of a noisy sine wave, but here's the trigger right up here, okay? And let's see if I can grab that. Well, I think that's part of, is that the trigger? I'm zoomed in so close, it's actually kind of hard to see. Okay, guys, I zoomed out a little bit. Whoops. Okay, when you mess up like that, you can hit this undo button right here. And let me bring this up here. Let me just zoom in on this again. All right, so here's that choppy looking thing. I'm going to zoom in on the horizontal scale a little bit. But I'm losing the waveform. It's going off to the screen, so I'm going to grab the hand and pull it this way into the screen. So here's our hystereses. And see, once it crosses 0, if you look at 0 line right here, it's right here. Let me put it right up here. Okay, that's how you can move that. So every time one of these things crosses 0, it tries to re-trigger. So now when I do it this way, it waits until this triggers, and unless the waveform goes farther than this down, it doesn't reset it. So it holds it, that trigger right there. Now I'm going to go back to the 12 bits again. And there's a nice sine wave. Okay. So that's what 12 bits does for you. And I can actually go to 16 bits on this scope. Now the problem is this is high frequency. Let's see what frequency it actually is. Let's go to measurements. I'm going to show you where the measurements are. They're right here. And we're going to go to frequency. And I'm also going to do RMS. I'll click on the screen and it makes that window go away. Okay, so it's trying to say I got 1 kilohertz because it's looking at this waveform up here in the full window. It's not looking at this. So what I can do, I'll show you the other thing, is instead of cursors, I have these rulers, okay? And I can turn them on. I'll show you the phasor rulers another day, but it has so many options. I can't show them all to you right now. So we'll do that. And then I'll bring this guy to one of the waveforms. I'm going to spread them out a little bit more even, make it a little bit easier on me. Well, now I spread it out so much I can't find my cursor. Okay, here, let's just bring this cursor over here. I could find them. I'll show you in a moment. So I can do this, and it's about 446 kilohertz. Okay, now see when I zoomed in like this, see over here, it put the cursors right here, so I can grab them right here, and I can go over here and grab this one. So it puts them right there. So if I go from here to here, line them up, you'd really want to stop it, freeze it, so it's not moving around on you. And it's 492 kilohertz. So that's the Class D switching. And that's how we can zoom in on it. Now also I have this vertical line, so I can go to the peak of this waveform and bring this up to the bottom of that one right there, I guess. So that line between this curve right here, it is 310 millivolts, peak to peak. So that is a Class D switching frequency, okay? Now I'm going to go ahead and close the cursors, and I'm going to close the zoom. We're back to this. Okay, I'm going to go back to running. So it's running. It's just holding nice rock solid because of that hysteresis. So let me just walk you through the screen. On the left, we have the 4 channels, and when I click in the middle, it pulls up the thing, and I could go by manual mode like right now, plus minus 5 volts, which means plus 5 volts, minus 5 volts. So it's kind of like 10 volts across the 10 grid. So it's really like 1 volt per division is what this is equal to. But the way they do it is they just tell you your bounds, plus 5 to minus 5. Okay, it's just a different way of doing it. And I have a DC coupled. I could AC couple it, but I like to DC couple just in case something happens. I can see if it gets a DC shift. Inverts off, offset 0, and I could zero out the channel, and if I click on it, it'll say, oh, short out your circuit. Well, I'm not going to do that because it's pretty much zeroed out. So, and you click on these little eyes, and it says digitally remove any offset from the input channel. Okay, so whenever you see that, it's a little helper. Now, if you notice, there's tabs across here. I'm on vertical amplification, and I can put this on auto. What I like to do is I like to put it on manual a lot of times, and you want to make sure this is the peak. Right now, I know the voltage is more than plus minus 5, so let's go see why we're getting what we get. Right now, I've got probe 1x selected, and I know this is a 10x probe, so if I go to standard probes, there's a 10x right there. And now I have to go back to this window and say auto. So to auto select, so it's going to plus minus 20. Okay. Now the trigger's kind of messing up again because that thing's not covering enough band. So if I pull it down a little bit more, is that going to do it? Not there. Okay, a little bit more. All right, that one did it. So there we go. There's all that stuff. So here's probes. The other thing is I actually put in a probe. I did the add probe, and I have this. So I'll show y'all. Put it in edit mode, and TA386 is what I called it. And I chose volts for units because it is a voltage probe. And see how there's a 2 and a 3 up here. So once I do that, then I'm going to go to the second window, and there's an equation, and I got 10x because I have the switch in 10x mode. So this is my scale. It's, 10x scale. So, or you could do a table if you had a table of values, which would be kind of cool, but or not cool, depending on how you look at it. And then the third window is this one, DC. These are all the default values. You can always change them. So low pass filter, which here I'm not stuck with just 20 megahertz. I can go 1 kilohertz or 100 kilohertz or whatever frequency I want to filter out things. So that's a cool way to get a nice clean waveform. So I'll finish that, and I'll go to see. So vertical, I had that 20 meg, right? And that didn't do a lot of filtering because this thing's only 400 something kilohertz. So I'm going to turn that off. There's a probe, and here's DSP. Now in DSP it says vertical bits 15, and that matches what I have up here. So and here's low pass filter. Now I can go to active, and I can see it's 1 kilohertz. Look how clean that sine wave is now. So I could go higher, and I can click in the middle. You can almost always click in the middle and get a menu like this, okay? So I can put in, like, say, 500K. And now I get to see that noise again. So if I could say 200K, whoops, I have to use the X to take it back, 200K. So it's filtering some, but not all of it, because 200K is not too far from 500K. So if I went 50K, it would give a, whoops. All right, there's 550K. See how clean that looks? So, and you can hit that 0 or whatever. I'm going to turn that off again, go back to the full window, and then display. I could call this gate drive or something like that, or class D amp output. So you can name things so that when you save these windows, you remember what they were. And here's a scale. Sometimes you want to scale things, and I'm not going to do anything with the scale. I'm going to leave that, and you can change the color at this point too if you wanted to. You can change it to any one of those colors. So lots of power in this scope. So we'll go back to that, and then I click in the middle of the screen anywhere, get rid of that window, and I'm going to come back up here. I'm going to go to just 12 bits because 12 bits was a lot. One thing about going to higher bits is you also lose frequency bandwidth, okay? So you want to be mindful of that. Now, I showed you trigger waveform. This is a new thing for most scopes users. This thing right here will save a bunch of these waveforms. See, this is a waveform right here, this window. If I freeze it, it'll save that. See, if I stop it, and if this is, 5 cycles, I could look at the 5 cycles preceding this. And that's waveform 63. I can go to 5 cycles before that, 62, 61. So let's say if you see a glitch, and it happens every so often, you can go back through these waveforms to see how often that glitch happened. So that's one thing you could do. You can also just capture a whole bunch of cycles and zoom in, but this is another way to do it. So, and sometimes this is, valuable. Sometimes this takes memory, so sometimes you want to limit how many waveforms. You can set that up so you don't get 64. All right, so here's your horizontal scale. Now I can choose 1 millisecond, 2 milliseconds, 500 microseconds. So I can choose things that way. I could also just hit the plus minus up here. But also, you see these numbers up here, sampling rate up here at the top? Well, that's this ADC. So you have access to that, which is super cool. So I can come in here and say target number of samples. Oh, what 100 kilosamples? Oh, what if I want to go a lot more than that? Get, a lot more samples. So I can go up to, let's see how high I can go. Now, what I could do, I'll show you in a minute, but I'm just going to do it this way, just see what the max is. Okay, 2 gigasamples. I could click on here and just select what I wanted, okay? Or I can use this scroll bar and do it that way. So I'll leave it at 2 gigs, see what that does. And then I'll go to sample rate and say, oh, 50 megasamples per second. Well, when I was up to 15 bits, it limited me. So let's see what I'm limited to now. Wow, isn't that crazy? I'm going way higher than you thought, right? 10 gigasamples per second. That's because it's equivalent time sampling. Okay, so it's pretty darn neat how you can do that. Now here, let's just go ahead and hit this magnifying glass and zoom in at the top of the waveform. Let's look what that looks like. There you go. Let's zoom in a little bit more. And that looks pretty cool, right? Now, if I want to do the horizontal zoom, I could just do the plus thing here. Maybe that makes it easier. So, pretty cool window. I love this window. And I love how you can just move it around, get it out of your way, put it wherever you want. So, that's something that I wish more scopes did. So, here's my measurements down here. It's still measuring that 1 kilohertz that it thought it saw before. Here. So, I've shown you a lot of things. Here's a really cool instrument window. We can go to turn this into a spectrum analyzer. Look at that. What is that? What do you think that is? If I hold the mouse down, see it says 400 kilohertz. That's that switching frequency, the class D. This is our harmonics of this. And then some of this is kind of falling off pretty fast. But look at that. That's pretty crazy, right? So now, that's because I'm coming all the way out here to 8 megahertz, well, 7.8, okay? So I can click up here in the middle of the screen. I can go plus minus, but let's just go down to, that's almost 1 megahertz right there. So that's, your 400 something K right in the middle of the screen. Look at that. That's a class D switching right there. Pretty wild. Now, let's try something else. Let's go to 20 kilohertz. There's our 1 kilohertz tone, right? Now, here, let's try to do something here. Well, here, first of all, I want to go to the measurements. I want to show you something. This is super neat. I can go to amplitude, peak amplitude, frequency at peak, intermodulation distortion, and I can go to signal noise ratio, the SINAD, SFDR, THD percentage, and decibels, and THD plus noise. And I can go total power. So I can do all those measurements. Pretty darn cool. Haven't seen that before. And so now I can scroll down and look at all that stuff. Here's the THD. Where's the percentage one? Right here. 1.6% distortion, it says. Pretty wild, right? Now, also I can come back up in here and I can go to this bins, and this gives me the resolution, okay? See, I can drop it down. Some scopes only give you 4,000. Some of the more, even expensive scopes that cost as much as this scope only go to 4,000. Some of those brand names we know of that, probably cost more than this scope only go up to 4,000. Well, I know they cost more, but, and so this is 4.8 hertz resolution. That's not bad at all. 20 kilohertz, that's not too bad. Almost 5 hertz resolution. Collection time's almost half a second. Now this is Blackman, so I could try any one of these other ones, like Hamming, for instance. Okay. Now, also I can go to axes and dB microvolts. Let's go to dB. Let's go dB volts. Okay. You even have an arbitrary decibel, and you can go linear log, and you can say how many decades you want to be. So there's just, oh, and you notice this too, normal, average, here's average. That really cleans up a lot of the noise because it takes some average signals. Now you click on this eye and it kind of tells you average and peak mode start accumulating traces when the scope starts computing. To clear the data, stop and start capture. Well, I kind of found that out by dumb luck. So if you're averaging and then you change something, it takes a while for this to change. So if you stop it and then restart it, see what it did? It restarts it and it re-averages things. So look at the noise floor, about minus 32 dB volts right across here. Okay, now I can go to peak and it's a little bit higher. So it's collecting all the peaks across the band and holding them steady. So that's the, wherever you get a peak, transient peak, whatever, it's going to hold it, okay? So go back to normal, and I'll go to running and stop. I think you don't have to do that when you're normal, but when you go to bins, 496, let's go to a little more resolution. See the bandwidth, the noise floor dropped a bit. And we go to 16, it's dropping more. So this is 32. Now we can go all the way up to, we can go all the way up to 1 megapoints, okay? And it's going to take 26 seconds to accumulate all that data. And we're going to have 29 millihertz resolution. So that's crazy good. So let's just go ahead and wait, and then I'll probably cut out this and then come back so you don't have to wait, okay? All right, so look at that. Dropped it down to minus 48. I mean, it's kind of crazy how long it takes, but, you know, it gives you some really good fine resolution. Now, I'm going to drop this because I want this to speed up a little bit so I can show you some things. Okay, that's almost real time, right? I mean, that's very little wait time. Okay, half a second right there. And we're getting really good resolution. So, I mean, there's nothing wrong with that. That's really great. Now, here, let me show you. I'm going to bring up the signal, and now we're kind of flat topping a little bit. Look at all those harmonics popping up. And look at the percentage. We're jumping up close to 3%. Okay, so now if I drop it down, right, let's see, I can visually watch it. Right there, it looks like it's almost done flat topping, a little bit of flat topping. You can see the harmonics even. And then right there, it looks like they're pretty much gone. And we're just barely over 1%. So if I drop a little bit more, it's hovering right around 1% thing. Now, what I think is if I do the average, see, it averages out and we get a little probably cleaner window to see what the THD is. Oh, that's IMD. Sorry, I'm looking at intermodulation distortion. Let's go to THD. We're down here at 1.68, and you can see some harmonics there again popping up. So I got to turn it down just a little bit more. And I'm going to turn this off and turn it back on so it clears the memory. So it doesn't take so long to change that. Okay, so look, THD, it's about 0.75%. Look at that. The noise floor down here is around 38 dBs. And our signals up here, let's see, we got that measurement, 16.2 volts. Wait, that's the RMS of the 1 kilohertz. Here we are right here. Frequency at peak is almost 1 kilohertz, it says right here. And over here, we have 22.9 dBs. So the signal noise ratio is 23 dBcs. So interesting stuff, right? Now this SFDR, that's the signal to the first spikes of noise. That's 51 dBcs. So if you look up here, we're up around, you know, whatever this is. If I click on it, it says 22.6 dBs. And if I come down here, it says minus 38. So minus 26 plus 38, that's the signal to this to the noise floor down here. So that's pretty neat, right? All right, guys, so then we're back in scope mode here, okay? So I've shown you a bunch of things. Let me just run through these real fast. The math channels, you can do these math things. You can say, I want to do my own math, and you can use any of these variables here, basic math here, use scientific functions here, trigonometric functions here, buffered functions, filters, and even couplers. That is crazy. All those different things. Hey, you know what? I want to show you something else. Let's go to more. I should have done this early on because maybe you like this better. Now, here, when I start up the scope, it'll go to factory settings, or I could set up user settings. I want it to default come up every time, or I can just say come up the last session. Okay, here's all the languages, by the way, bunch of languages. Okay, let's go back here. So I'm sharing statistics with Pico right there. Kind of says what they're doing, helps them out. So I'm okay with that. So here's light. Here's what I was going to say. I probably should have done this a while ago. Let me know in comments if you guys like light or dark. Okay, so I'll use light or dark in the future, depending on the votes down below. Okay. Here's trace line thickness, so you can make the traces thicker if you like thicker, or thinner if you like thinner. So it's started off at 1, I'll leave it there. Side panel position, you can put it on the left side. You can switch over to the right side if you want. I think I'll leave it on the left. I'm kind of used to it being there. Measurement system, metric US or default, whatever that is. Okay, so that's under this, which includes a whole bunch of things. Okay, so I'll let you look at that. But I want to go over here and say there's views. Views is a real cool thing where you can say, hey, I want to have a spectrum view and I want an XY view. So I got my XY view here. The window's kind of small because it's broken up into thirds. Otherwise, this window's, pretty nice when it's full screen. I'll show you here in a moment. But see, it's neat how you can get all three of these windows all at one time. And you can select a window, you can pull it out like I just did right there. And I can enlarge it, or I can, like that. Okay, one more thing I want to show you in views, guys, is I got rid of all those windows, started back to the scope. But here, let me bring it back again. I just want to try one more thing I think I forgot to show you. If you go to this view per channel, this will discard your current view setup. All right, so yeah, I thought that was something else. I thought it was allowed to show hide channels A, B, and C, D. Oh, if you have different channels on, you can turn them off right here. So you can have different windows. So you can have, say, if I had all 4 channels on, I could have one window with just channel A, one window channel B, one window. So all 4 would come up automatically if I had them all turned on. But then I could pull up 4 different windows, and each one I could turn on and off the channels I didn't want. Okay. And here's the auto range. Oh, that's what I think I wanted to show you. Yeah, sorry. Version 7, I'm still getting used to it because it is different than version 6, and it's a little bit different than the early one because they were making updates all the time. So, where am I? Auto range. So it's already auto range, I guess. Reset. So yeah, display XY view. Oh, so display XY view at 1:1 aspect. Oh, so you can turn it off if you don't want the box, and it just stretches it out for the screen. That's pretty cool. I haven't seen that before, but sometimes you want this because you're doing those patterns and you want to be the same, axes left and right, same aspect ratio kind of thing. So anyways, let's go ahead and turn those off again. And we're back to scope. All right, so that's enough with views, math channels, serial decoding. Lots of decoding. CAN buses, all kinds of buses. Look at all these. I2C. Here's Mill Standard 1553. ARINC 429. Modbus, RTU. I mean, just all kinds of them. This DCC, what is that? That's an interesting one. Here, let's go to next. I selected it. Okay, so you choose what channel is data, and then you go next. See, there's 3 windows up here. I don't know what I'm doing because I haven't seen this one before. And you can name it right here if you want. You can change whatever format you're using. All buffers, current buffer, decode off and decode on. That's pretty darn cool. Oh, decode between time rulers. So you can set up rulers so you can only decode between them, so you can tell it where decoding takes place. So then I'd say finish, but I'm just going to cancel that. Now, whenever you do setups like that, they'll show up right here. So that way you can jump to the math where you did before. So when I did that math, so I want to delete that, get rid of that. And decoding mass, you know, that's something that I could do in another video if you guys want to see how mass works. Honestly, I played with it on different scopes before. I haven't played with it on this scope, but I think it's fairly simple. You say what percentage of the mask you want, and then if you get another waveform that fits inside this mask that I just opened up, it's going to pass. It's like a pass-fail kind of criteria thing. You can export this to something else, import it. So if you export it and save it, you know, if you're on a test line or something, somebody wants to test this channel at 1 kilohertz and make sure that it falls within a certain band. Like maybe I want to be real close to that signal that I'm seeing right now. I'd say, okay, let's do within 1%. I want everything to be within 1% of this. So somebody gets another one of these amplifiers, puts in a 1 kilohertz signal with a certain amplitude, and if it passes inside that band, it's a pass. If not, it's a fail. So you can use it for things like that. So I guess I just kind of showed you that, but if you want to look at different waveforms, more waveforms, and how to set that up, we can do that. And actions. Actions, I think, are, okay, there are these events you do on these buffers. So you fill in a bunch of memory in a buffer with this screenshot, and then it does it again and it does it again, kind of like this waveform thing up here. But this is on an event. Like every time it triggers, it'll say that's an event, and maybe you're looking at that transient. So every time it sees that transient, it saves that event in these buffers. And so you can do all that, and then you can say add that, and what will happen is it'll put it right here. So next time you want to do it, it's right there for you. So let's delete that. Oh, notes, really cool, because you can come down here. See, now I have a notes tab and a measurements tab. I can go back to my measurements. I go, oh, what's my notes? And I can write some notes. Hey, this is when I was doing 8 ohm resistor load, something like that, with, you know, 1 volt RMS input, you know, something, you know, you can just make notes. It's handy. So pretty cool. And if you want to get rid of them, just hit that X and get rid of it. If I want to get rid of all these measurements, I could do the same thing and hit that X. I'll just leave it there for now. Rulers, I kind of showed you that, didn't I? Did I? Turn them on, you move them around, measure stuff. I think I showed you this, right? I forget. And, you know, you can look at your frequency like this. And you got this window, and again, these windows are super cool because you can just move them around where it makes sense instead of stuck in the same place in your screen all the time, which always drives me nuts. So I love this. Love how flexible and all the things you can do. Deep measure, another really cool feature. Let's say if I'm going to deep measure this signal right here, channel A, I turn that on, and I can name this. And I can set up these things here. I can set up rulers to just measure between rulers or whatever. And then it gives me a whole bunch of data down here. Now this is stopped right now, so let me turn it on. So it starts capturing data, okay? Let me turn that back on again, channel A. And should I turn that on? Anyway, so normally what it does, I'm not sure why it's not doing it. Maybe it's, okay, I don't have all buffers, so I had just current buffers showing. So you have all these buffers. See the numbers over here? And if I scroll to the right, you can see all these different measurements it's taking. And it's just looking at this waveform, taking a bunch of math and taking all these measurements, fall time, all this stuff, and it's putting it in a file. You can export it and look at it in Excel, I believe. And I haven't done that, so I'm just saying that, but I'm pretty sure that it's an Excel field. And here's different fields that it's measuring, all those things. So turn them on, turn them off, that kind of thing. Okay, so now I can come back to see again, it puts it down here at the bottom of the window. I come up and say, oh, delete that. I'm done with that. Don't need it. Okay, so I've talked about all the things across here, showed you that, showed you startup, open, pretty self-explanatory, save files, name them, put them where you want. So you got all kinds of information you can add. So it's pretty cool. You got notes down here, which is pretty cool too. And print, and you can go full screen with your, to get rid of all these things on the side, which you can't do with other scopes, right? You can fill the whole screen. And if you have separate, more than one window, then it helps you fill in all that time. So Control F or hit that. So pretty cool stuff, right, guys? So there you go. I hope that was kind of fun. And you see that Class T thing. You can see how you can look at the FFT and see the 400 something kilohertz noise stuff, and you can see how nice the FFT works on this thing. It's like a spectrum analyzer. I mean, it's really easy to use. Yeah, really happy with this scope. So hope you guys are as impressed as I am. All right, guys, so what do you think? I got carried away with the scope, showing you the features. Wow, there's just so many features in this scope. Feature rich is, a good word, I guess, or maybe not even good enough. But yeah, there's tons of features on this new software. It's really amazing. The Class D amp, I'm going to look at this some more, do some work on this. Let me know if there's signals you want me to probe around or look in this thing. This is that ICE amplifier. Man, it's been kind of fun playing with this scope. This new software, I love it. But I love the Pico scope. Once I got it hooked up, I get carried away, you can tell. I've been here all day long. I took a break to go to a going away party, but I was only gone for a short time. I've been here since morning, and this is late, 10 o'clock at night right now. And yeah, I've redone this video 5 times, I think, because it was just too long. So it's still long. Sorry about that. I want to give 2 thumbs up to my patrons as always. Really appreciate you guys. Appreciate you guys. You hit that super thank you button down below. If you guys like this video, if you like that Pico scope, let me know in the comments. Let me know if you like the dark screen or the white screen. I kind of like the dark screen myself, but let me know what you guys do. I mean, this Mixig, I got it set up the same way with the dark screen, back screen. So I was using the Mixig to compare the signals here, and pretty cool. I've got the GW Instax up there. I've got some nice scopes. I really like this Mixig right here because I like how the small size and the probes and everything. But the Pico scope is just so powerful that it's just really fun to use. And using the Spectron on it is a joy. It's even easier than the GW, I think. It's just, they all have 1 meg points of data that they collect for FFT, but the measurements on the Pico are way better than any of the other ones. They just don't have that many measurements, so it's really neat that you can do all this stuff. But what do you guys think? Let me know in the comments below. Appreciate it. And whew, man, I thought I'd get this video out before I went to the party this afternoon, but that didn't happen. So probably not getting out till you're probably watching this Sunday morning. Sorry about that. So if you watched all the way through, thanks a lot, guys. Thanks for watching. Appreciate it. Like the video. That helps. You guys know the routine. Subscribe if you haven't done it. If you think you've subscribed, just check. Look down below. If it says subscribe, YouTube unsubscribed you for some reason. So yeah, that happens, I heard. So anyway, thanks a lot, guys. We'll see you next time.